think it's 10 after the hour, so even if we're fashionably late, I think that's a good time to start. My name is Irfan Ibrahim, and I am the Director of Cyber Physical Systems Security and Resilience at the National Renewable Energy Lab. It's my third week at the job, so I'm still on my first of the 3 envelopes. And since there's no predecessor, there's nothing to worry about. So I can't blame anything on anyone before me. This is a new practice that we have developed at NREL, primarily to focus all the interest in cyber physical systems and in resilience as we see increasing amounts of renewable energy coming on the grid. So it's a cross-cutting function. And I've just recently joined the group, and I'm building this research center. So it was a coincidence that they asked me to moderate the IoT panel because cybersecurity and resiliency is going to be so important when we put all of this infrastructure out. So I'm going to start by saying a few words about IoT, some of my thoughts, and then I'll open it up to Dirk over here, who's with Energybox, and then Tracy Trent with Proximetry, and then Brian Huey with Sprint, and John with Fujitsu, and then Ernie with Verizon. So I wanted to make sure that I said the service provider names in the right order. Now, as you know, we started out in the old paradigm with very few systems being intelligent and even fewer being smart. So now let me distinguish between intelligent and smart. Intelligent means having lots of data. Smart means being networked to take the data and turn it into actionable intelligence. So in much the same way, there are people who are very intelligent, but they're not very smart. So they constantly need funding from external sources to keep their intelligence going. But smart means how do you bring money and thought together to do something, to help society, to generate wealth, and so on. So think of it like that the electric sector is also evolving from having been intelligent to being smart. And where that paradigm shift is occurring is where the communication networks are coming, where sensor technology is developing and is getting internetworked, and there is a new form of architecture being created in layers that allows for federated systems, if you may, pushing the intelligence further and further out on the edge. This is monumental. This is huge. So kind of like if you take the model from the enterprise IT side of the business, you remember the old days when you had the mainframe, and then you had a bunch of dumb terminals. And then as electronics technology improved, we moved to a client-server kind of architecture. The PCs became more and more intelligent. We started seeing the development of the network. So keep that paradigm shift in mind. But in the last 10 years, if you look at the form factors of sensors and how rapidly they are shrinking, and then you see the increase in horsepower in terms of processing, the memory, you can have lots of memory right over here. So those huge changes in technology are naturally going to have an effect on the economy. And the way it's having an effect is that the ability to take physical phenomena that's usually occurring in an analog form with the use of sensors is turning into digital information. And that digital information is being merged in some kind of a device out at the edge, and selectively information from that unit is being sent back to some central place where there are softwares to do detailed analytics work. And there's some kind of a human-machine interface that allows regular people to take that process data and do things about it, make decisions from it. we saw a great presentation by Tom Siebel of an example of that with the C3 offering. And there are many players in this market. So what I'd like to do with that background is each one of you tell us a little bit about yourself and what your role is in your organization and how you are involving yourself with this paradigm shift that I'm talking about. Starting with you, Dirk.
Thank you, Evan. Okay, my name is Dirk Beiner. I'm CTO of Energybox. Okay, let me start off a little bit from a history point of view. I'm a little bit new in energy, but we come from lighting business. And in my previous company, I worked for lighting control systems and went the whole transition path from incandescent analog lighting control systems, where you have basically a dump light switch on the wall, and that goes majorly to the point that you have dimming capabilities, down to the road that LED has been introduced into the market, and the LED introducement into the market was a way more demanding, channel demanding, control demanding data point that was quite disruptive to the market in many ways. I mean, everybody of you is aware of how LEDs changed the market in lighting already big time these days. But also in the infrastructural way, you see that this industry, the lighting industry, hasn't been prepared for this one in many ways. So if you look at the data systems that have been in place for, I mean, the traditional light bulb is there for 100 years already. If you look at the data systems that have been introduced into that area, in that business scape, the last 100 years to control this light bulb, there was almost no invention in that. I mean, even a traditional light dimmer was not really looking for what he's dimming. At the end of the day, it was basically just a dimmer and doesn't care about the light bulb behind. Now the LED came in, and the LED was asking, oh, wait, I can change color or even color temperature. I can change brightness. I can change this and that. So those systems haven't been prepared for this. And when we started working in that field, basically it was very disruptive in many ways. By that time, because you try to put on that infrastructural data buses that were, it's like you put buses on tracks that were more designed for bicycle rides, which they wouldn't last that long. So that was quite disruptive in many ways. Meanwhile, I'm off that business. I went to energy now. We looked at the energy business, and we see some similar paths here. So to see that, to make the turnaround to energy now, I see a very similar path here. So when we look at energy right now and how to increase energy efficiency, the energy efficiency world, that is the biggest topic right now, how to increase efficiency. That is a more global thing, and the awareness is getting there that something needs to happen. We started to think about it, where to start from, so where to look at. And first of all, it starts with understanding. If you don't understand your energy consumption, or if you don't understand what is going on with energy loads, then it will be hard to act upon. First, it starts with understanding. So what we did is we looked at the topic there, and to our surprise, it was not that well understanding there. So let me maybe ask a question. Who in the room, of the audience, knows his kW hours consumption per month, just as an off-the-head number? That's 0. And anybody an idea about how many breakers he has at home? As well, 0. Interestingly, that you find all over the places. That's a very interesting response on that one. So we looked at the topic, and we look at the breaker industry. It is very similar to the lighting industry. It has been there forever and didn't change forever. So that is really interesting. So we looked at the breakers there and said, well, guys, whatever we connect electrically to the power grid, it will be handled by a breaker at the end of the day. It all comes back to a breaker. There will be no escape on that one. So it all comes back to a breaker. So how can we apply something as a retrofit so that we can get hold of the data that's inside this breaker? Because the breaker has the information somehow in there, but we need to extract it. So that's where we jumped in and said, okay, we develop a sensor that you basically put on a breaker, and that this one captures the information that is going on the breaker and shifts it into the cloud. And this data is later on being used to make useful applications on it to bring value to the customer. Because energy is still, energy for the majority of people out there, energy is treated more as a painful thing.
So hold that thought, because what we want to do is do a lightning round here of introductions.
Okay.
And then we'll get into the meat of the subject.
Okay.
The O of the IoT. All right.
O of the IoT.
Tracy.
I'm Tracy Trent. I'm the CEO of Proximetry out of San Diego. Proximetry builds a network and device management system for IoT called AirSync. We like to think that our view of the world of IoT is quite vast. You find AirSync on everything from airplanes to light bulbs. And in the middle of that is the work that we do in smart grid. It's interesting as I kind of reflected on what we might talk about in this. The thing I like about ETS is we all like move so fast and we're running around. Is ETS is always a great point to kind of come back and reflect on what's changed. And it was funny on this topic. I remember 2 years ago there was an exec from Southern Company here, and she was talking about when the tornado basically came through their service territory, that they were actually able to use the smart meters to determine what parts of the infrastructure had been damaged, just by simply pinging the smart meters. And I remember putting in my notebook there, smart meter is a sensor. And so it's kind of funny as we fast forward to today and we talk about what some of the utilities are doing and looking at their smart meter networks and what they can do to try and extract more information. Not necessarily more information about the consumer, but just about how things are operating in general. And one utility in particular that we're working with, we went back and they have a very mature smart meter installation. And we're talking to the meter manufacturer about what additional information you do. It's like you can't really extract more because you can't change the meters out. But it's funny when you tell people they can't do something, what they figure out. And you start looking at additional things you could put into the loop, including putting additional meters in the loop. Not necessarily because there's another house, but because you can inject another meter as a sensor to detect what the other meters are doing. Algorithms in the meters, right? I didn't realize it, but when these things reboot, and they look at other devices that are adjacent to them, or you put other gateways in the loop with other sensors on those, and then you look at the back-end data behind that, and you pull all this information out, correlate it with what the meter data management system thinks, you get a lot more behavioral information about the network. So it's kind of funny that we look at that and we look at the meter manufacturer says, well, you can't really extract anything more, but in this case, the utility really was able to get a lot more data. The thing to me that's interesting on the horizon is all the discussion upstairs about solar and other forms of renewables. And we're very intrigued because we're working with some of the same meter manufacturers now to actually take their new generation of mesh network into new applications of renewables or even adjacent utilities, gas and water. And we look at kind of the mesh and the meters on the houses, but you now look at solar arrays being installed on the house and how you can connect all of the sensors that are there. And it's funny, how many sensors do you all think that there actually are involved in a typical solar installation? I was surprised. We talked to one solar operator and they said, well, today we've got kind of the inverter, the gateway, the meter, we've got Uncle Elon's storage unit that we're putting in here. But then they fast forward and they start talking about these microinverters and houses that could have 40 or 50 sensors. And you look at that, and it really tells us how vast this opportunity is and the data that's out there.
Right. Great. So picking up on Tracy's comment, my name is Brian Huey, and I work at Zpryme in our machine-to-machine and IoT group, focused on smart energy and smart grid and utilities, and I've been doing it for several years. And so I was reflecting on what would I tell the energy thought leaders, of things that I'm experiencing in the IoT space and things that my peers are experiencing. And I think that, it's important to take a step back because sometimes we get wrapped up, is the smart meter going to be the gateway into the house? What kind of analytics can I derive from a smart meter? It has to last 20 years, is some of the stuff that we hear. And I think it's important to take a step back and think about, well, let's look at the environment that we operate in. And the first environment is that from a bandwidth perspective or a carrier perspective, bandwidth is increasing anywhere from 25 to 50% every year from a wireless company perspective. I think Ernie would agree with me, like last year and the year before, you might get a couple megabits per second or up to 10 on the LTE network. Now you're getting 25 to 50. Later this year with carrier aggregation, you're going to get up to 200. Across the wireless network. And that's just one version of LTE. And there's all these different versions that are coming after that. Second thing is it's important to keep in mind, especially in an IoT session, with all the stuff that I work on a daily basis that's not centered around the meter, but it's centered on HVAC or solar. We heard some of that, distributed generation, energy efficiency, water. Is that there's Metcalfe's law. So as we build, as Ernie and I and our peers and Ed at AT&T, we build these connections into these devices that there are n squared types of value that can be derived from that. And then the third is, which is really key to this discussion, is kind of what I like. It's Groves giveth and Gates taketh away, right? So we all know what that. Andy Groves at Intel, and Intel's fabrication and processing power, and I think it's really important to think about that in terms of a 10-year-old smart meter. Is it realistic to be pushing analytics down to the smart meter device, or is it more realistic that that smart meter device, or as I call it, a probe, is reporting back to the cloud? And the number crunching and the machine-to-machine analytics are being done in the cloud, which is occurring today. But what kind of keeps me up at night, and we were talking about this. You've got a great metaphor, so I'm going to let you talk about it. But there is a part of the business model that's not being monetized right now. We are monetizing the connectivity. We're connecting all kinds of things. And I've got a cellular modem right here. This is 18 months old. So the current generation is about half the size of this. There are some meter manufacturers that are putting in a modem that's very similar to this. It's about a quarter the size with a quad-core processor. Right here. So you can connect a variety of different devices today, and you can do it for $20. That's your hardware cost. It's pretty inexpensive. The thing that keeps me up, though, is who is monetizing? Who's doing the machine-to-machine collaboration? We're doing machine-to-machine connections, but who is doing the machine-to-machine coordination? Who's taking that HVAC efficiency data or that EV charging data and feeding that back into the utility, and the utility is creating some kind of actionable intelligence out of that? So the thought I'd like to leave you with is, while Ernie and I are extremely busy connecting all these different devices, the people, the entrepreneurs that are going to monetize that, you saw a little glimpse of that, and that's Siebel's group, right? C3, who are actually doing those analytics in the cloud and taking actions based upon that. And so that's what I'd like to leave you with.
So John, give us, you come from a hardware, heavy-duty thing with software layers riding on top. Tell us from your perspective where you're seeing this paradigm shift for IoT.
Yes, thank you. My name is John Chowdhury. I'm a director of utility practice for Fujitsu Network Communications. And my background, actually, for 27 years, I've been working in the utility industry and some with the comm sector or communications companies as well. And my answer would be really not from so much about Fujitsu's perspective, it's utility perspective. And what I see the biggest impact of IoT is really bringing this end-to-end, from toaster to turbine, the concept of smart grid to realization. So if you will, the smart grid, when we talked about it, and the first set of sensors that went into the meters, and we have done that, right? So now we're talking about monetization, we're talking about analytics, and a few other things. But how about this from low voltage lines, from transformer back to substation onto transmission line to a power plant? So when you look at power plant, you talk about different kind of power plants, including renewables. The intermittent nature of the renewables the impact of that in the capacity or the transmission and medium voltage to low voltage lines. These particular areas are particularly dumb, as all of us know. And so how do you make that smart? And this is where the IoT will play the biggest impact from the utility perspective. And if we can energize those areas, we can truly get to turbine and monitoring it so that we can get the impact or the efficiencies that we're looking for from a smart grid, from operational perspective, from generation perspective to the consumer who's be using these data points. So from my point of view, utilities have a tremendous opportunity, because one of the areas over the years when we talk to T&D vice presidents or T&D people that work on the T&D side, they have not found or they have not seen a whole lot of innovation in their particular part of the business. So if you will, a transformer today is dumb. A reclosure, fairly dumb. Now we can have automated reclosures, for example. But what if we can make those intelligent so that they provide us enough information from an outage perspective, so you don't have a rolling blackouts, or you don't have the impact of a high voltage or low voltage or impact of renewables into a particular grid area, if you will, that can cause issues. So just to stop there for a minute, is that there are a whole lot of stuff we can do. And from the Fujitsu perspective, as our colleagues over here focusing on other areas, we're there, we provide the transport layers. So more the data, better for us, because we sell the, if you will, the plumbing for the whole network components. So it's exciting time ahead.
Ernie?
Very good. Well, thank you very much for the opportunity to participate. I'm Ernie Lewis. I'm with Verizon. I lead a global marketing function focused on the vertical of energy, among others. And I want to kind of give you my perspective that goes a little bit broader than the technology. My background before coming to Verizon, I actually worked at a large IOU for 27 years, both on the business side and the IT side. And I interact with the IOUs, the rules, the co-ops on a regular basis. And one of the biggest challenges that I see people facing is really understanding what is their business strategy around leveraging technology for business benefit. So when we talk about IoT, we know that it has to have a level of awareness, actionability, and autonomy. That's great. But at the level of actually affecting change of the business, it's really about sensing, transporting, storing, being able to analyze, being able to take action, and be able to share the data. And there needs to be a coming together of that business strategy to really recognize the value and the potential within IoT. And so from our perspective, we are involved in helping to enable the entire array of capabilities within IoT that go beyond just the transport layer into the storage and other things. But the way I see it is there has to be a connection between the consumer side and the grid side. If you really want to unleash the power of IoT, you really have to be able to build that bridge that connects both sides of this, right? You have to be able to enable the two-way communication and controls that allow you to take decisions that you can now make, turn them into actions that can yield actual benefit. And that benefit has to be measurable, so you can actually return it back to the consumer or to whatever constituent you happen to be working with. So I hope that as we go further with this discussion, that we'll explore all these different things. We know that the cost of the technology is definitely dropping, right? Moore's law is always in play. The cost of sensors gives us a different way in which to phase them in. Now, instead of having to buy one that perhaps is giving you more than you need, you can actually separate it into low power, low voltage sensors. You can apply them where you need them as opposed to some of the ones that have even bigger capabilities. And it gives you a way to have a deployment that matches your investment strategy. I think we're going to continue to see that moving forward in this space. I think we're going to continue to see people that can actually let the business scenario and the business value drive where the technology needs to go and the interoperability and how it needs to go forward. In the interest of time, I'm going to stop there and turn it back over to you.
Okay. So now I'm going to be a bit of a contrarian. and suggest the following, that there seems to be a contradiction in trends. So Moore's law is helping us reduce our form factors, have more efficient processing, and more memory, and so on. So one would think that logically that would lead to more federated systems, distributed intelligence. And then I hear a multi-billionaire on stage talking about the need to take all of this back into a cloud, massage it, and create sophisticated analytics from it. My contrarian view says, as a cybersecurity guy, all I need to do is be that ant that rides up that trunk of the elephant and lodges itself just right in the sinuses of the elephant to bring the whole elephant down. And the mitigation to that is to push intelligence out further, make decisions as local as possible, take summaries back up that have no strategic value, but take away that real-time operation lifeline from going all the way back, because that's the analogy of the trunk and the ant. So with that contrarian view, tell me, how do you digest these two diverging philosophies? One where, because of processing, we're seeing federation, and then you see high net worth people talking about aggregation and people listening to that.
So, well, could I?
Yeah.
There's a very real example, because Ernie and I live this on a daily basis in the IoT space. You're dealing with an $80, $85 smart meter. And every piece of material that you add to that one particular manufacturer's smart meter, disadvantages them from a cost basis to the others. Now, sure, there's value you can extract from adding that, but when you multiply that times 1 million or 2 million meters, and then you ask the ratepayers to bear that cost, I think that's why you're not seeing that type of intelligence down into the meter, even though Moore's law is there. Moore's law will benefit the next generation of meters. Now, like companies like Varentech and Deepak's product, which is fantastic, with the Engo product, they'll do voltage set points, and your intelligence is at the grid edge. But there's also analytics that's being done. The reason why you're not seeing more of that at the edge, from my perspective, is that you're under tremendous cost pressures to keep that individual device down to ensure a reasonable ROI. Yet your data analytics, machine-based learning or AI, or whatever the soup du jour term is today, is much cheaper to be done up in the cloud.
So let me spell out my contrarian view a little further. Notice I never mentioned smart meter as being that edge. What I'm talking about are autonomous zones that have business significance, that have intelligence at that hub. And that may be at an access point in an AMI system. It doesn't have to be at the meter. It may be a microgrid controller in a consumer facility. The entire grid could be thought of as a set of fractals, breaking up voluntarily into a set of microgrids, skinny, but still microgrids, in the form of natural disasters, where Syracuse, New York, if I recall, when we had the 2003 blackout, involuntarily became an island, and there was light there where there was darkness all around. But I see with Internet of Things, with sensors, our ability to create these meaningful zones. Let me tell you, just from a cybersecurity perspective, the value that will create. It reduces the strategic value of data. And that is the biggest barrier for hackers to pick that vertical versus another vertical. If you look, banking and finance or social media, it has a lot of hoopla. There's a lot of news when something is compromised there. But if you just hack, let's say, 500 meters in a residential neighborhood, it's not going to have that same level of strategic value. So I have, this is where I want to bring in the discussion that how do you balance between the federated architecture that has more resiliency and more security versus the centralized one where you can derive business value that's not scalable down to those elemental levels, the kind of crunching power that we were talking about in C3. So, John, you want to take it, and then Dirk? Okay.
Okay. So from my point of view, this is where, as vendors, we need to play a bigger role in understanding the value chain, because I think all too often the vendors particularly focus on their particular area and trying to put that square peg in a round hole. And I've seen this over and over. You know, you talk to a AMI vendor, will be focusing on their AMI domain only. In all fairness, you know, it's not universal, but nonetheless, that's what they focus on. So, for example, when you look at Fleischer or fault location isolation restoration process within a medium voltage to low voltage grid, yes, you can isolate that. I can minimize the outage that can impact in a particular area with that device. Now the question is, that device today, with some of the bigger vendors, $25,000 each. And to be honest with you,
software.
I'm sorry?
Proprietary software.
And of course, proprietary software and proprietary communications protocol. And again, you know, when I talk to some of the utility executives, you know, the problem is that the utilities have reacted and actually adopted some of this technology because they didn't have any choice. Nothing else was available. So today, you know, if we look at that as an example, and we could do very same thing within a transformer that can isolate, you know, 10 to 15 houses, let's say, within a community. So our, you know, the way we need to look at is the value chain and isolating those things so that we don't have this blackout that causes like what happened in the Northeast. We just didn't know it even. Yeah. So I foresee this, you know, there are some examples already been set, like for example, this $25,000 device that only, you know, you have to have so many to cover even University of Texas and Austin area. I mean, you're going to spend a couple million just to isolate those problems, restore it. And this is actually, the intelligence is distributed to that device. So it actually makes the decision right there with less than 10 milliseconds, and then sends the data back to the SCADA and the network operations center so that further decision could be made. So same thing could be applied elsewhere, and with non-proprietary in nature, thank you for bringing that up, we can actually use IoT to actually strengthen that grid.
Dirk.
Okay, from what you just said, IoT, first of all, my view is IoT is making the world visible to machines. That's right. Basically what they're all doing right now. And if I look at this, method right now, those machines will be able in future to find solutions to problems that are more complex that human beings can solve instantly. So they will find really clever solutions to problems that we don't know yet right now. So it's good to create systems that are flexible in many ways right now. But now that we are at ETS right now, focusing on energy, energy as a service, if I look at energy as a service, then the meaning of the word is that it serves the customer. And the sensor itself doesn't bring any value to the customer right now. It's just an IoT sensor that reports this information somehow to the cloud, but that is meaningless to the customer as long as he doesn't get any value of it. So the question will be how we convert this information into something useful to the customer. And the more complexity we put behind, the more decentralized and the more collective machines we will put in place, to come to your point, that will basically try to be adaptive to solutions that we face in future. Because we might not see right now what's happening in 10 years or 5 years from now.
Yeah. So
can I chime in on this?
Yes,
because
please.
One of my favorite topics. This is all about processing power. With extra processing power, what do you do? Yeah. So Tom Siebel stands up and says, you give me all this data, I can figure out a way to do extraordinary things for operating efficiency. And he can, right? And the utilities will continue to deliver more and more data to the cloud. They'll find new and different things. So the same thing exists down at the sensor level, though. Like you said, We've got people that are building these new chipsets. They're not giving me the extra power because I want it. They're giving me the extra power, the extra wireless because they can. So, you know, I get a small platform. It's got a couple of cores in it. It's got BLE and Wi-Fi and the rest. What ends up happening is the utility now can end up throwing sensors everywhere and do local event processing. That's all about command and control. And so what I think is interesting here, and fractals is a good way of describing it. Yeah. We all like to talk about smart grid, and we always focus on the hunk of metal that's sitting on the house. But I'll take a different example, which is pipeline safety and the gas side. And the example there is, you know, the utilities putting out gateways and sensors for methane and strain gauges and things like that. But because the cost of the sensors have come down so much, they can afford to throw more sensors. Because that's exactly what they're doing. They're throwing accelerometers on fences. They're throwing motion detectors. And that edge processing there is to basically correlate events at the edge of that little gas grid, if you will, and determine, wait, there's a methane sensor that's been thrown, so what else do we see that tells us there's a bad event happening? So I think it's interesting to see the processing power split to more of this efficiency versus command and control.
Ernie.
Great. I want to come back and just say that I don't necessarily think your view is contrarian. I think it's actually complementary to the conversation. Okay. We talked about IoT, of having a degree of being autonomous. That's really what's required to do what you're actually describing. We talked about it being actionable, right? That's also part of it. So let me kind of paint a little different picture. When you think about the utility landscape and the fact that they can throw sensors on more things because the cost has come down, once they consider this, they now have an opportunity to consider how to operate that grid as efficiently and as effectively. So the analog I would offer you is think about when we first began to network computers. There was a degree of intelligence that sat in one location, and a lesser degree, but still some intelligence that sat at the distributed locations. Think about a world where you're able to have all the information coming in from the sensors, but instead of home running it all the way back to central office, you're stopping it. Perhaps it's an intelligent router. It's a router that has an operating system on it that allows you to do some calculations remotely. And then you're only bringing back the data that you necessarily need. You have now met some of the challenges that you were describing by separating what data is going where and not necessarily saying I'm in the elephant's trunk, if you will. Yeah. I also think from talking to our utility customers that two things that they're really concerned about, among others, is interoperability and standards. Because really, if you don't have that, then you're not going to have a true Internet of Things. You're going to have a bunch of villages, right, that stand alone. Mm-hmm. The second thing are defined platforms. So as opposed to having to Lego block everything together, you have platforms that can provide you integrated security, integrated transport, integrated resiliency, as opposed to having to hop in and out of different assets. So I think it's part of the road and the evolution that we're actually taking. And I think that's part of what I meant when I said it's about using technology to leverage it for business benefit. That's a benefit to how the business operates, being able to isolate that information and manage it appropriately based upon actual need.
So let me carry this logic further. What Ernie has described is he's trying to avoid the wag the dog model, where you have a solution and you're looking for a problem. And that's a wrong way of doing it.
Right.
I think that as long as energy costs for consumers stay 6 to 8% of median income, you can process the data all day long about energy. It's only going to have so much strategic value to a consumer. And it'll be very hard to monetize that until you start linking it with other aspects of their lives. And this is where I see the real Holy Grail, is how do we transition from a siloed energy focus to a more broad smart city focus where healthcare, agriculture, education, water, wastewater, oil and gas, and energy are all coming together on a platform that has tremendous commonalities. What are those commonalities? Some kind of sensor out in the field measuring physical phenomena and turning it into digital data. Some kind of a merge unit that's bringing that disparate sensor data into a protocol which a SCADA system can use to do command and control, as Ernie was talking about, and putting the appropriate barriers for data not to come in. Like, you don't run a session all the way from the central all the way to the edge. So on the reverse path, the virus comes in with it. No, you break it up, you look, and you do whitelisting of applications. You do zero-day attack protection through situational awareness. Look at the context, job description, and based on that, you figure out things. So when you look at it as a smart city, then you put in energy as an additional value in that stream, people start seeing the big picture. They want it because it eases their lives, it creates new jobs, it's prosperity. So talk about the broader concept of the smart city and how the IoT revolution is going to enable that smart city.
I'd like to take a step back because I think that's the panacea that we want to get to.
Yeah.
The reality that I work in at Zpryme is that I'm monitoring a medium voltage line sensor and reporting the line characteristics back to the utility, or you're monitoring a recloser, or it's a smart meter, or as I was talking a little bit with what Ernie was saying, and Dirk and I were talking about this, is you can buy platforms today like the Intel Sophia platform, which is very similar to a Raspberry Pi with a 3G modem, and it's $100, right? So no longer do you need this for 20, you can get a full platform with an operating system, and you're good to go. So that creates the intelligent sensor, and the innovators and developers that are doing that today are doing that to deliver on a specific ROI, like Dirk and others, water meter vendors or these sensor companies that are providing that value back to the utility. The intersection between the utility and the smart city, you have different companies like Silver Springs that are trying to leverage their infrastructure and going after that. But there are still some unanswered questions as to what is the business model that's being set up if you're not a municipality, if you're an IOU with a utility. So, from my perspective, from the day-to-day operation perspective, we're connecting these irrigation sensors, these power sensors. We'd like to get to that automatic islanding that they show at Distributech, and when you walk through, I think it's Schneider's booth, where they show the fault and everything reroutes around the fault. But,
so before Dirk, you go, I'm going to tell you something from my crystal ball. My crystal ball says that smart city as a concept will become a reality in third world countries, developing economies, far faster than in developed societies. In the same way today, if you go to a third world country and look at the cell phones they're using and the network that they have, they're even buying and selling stuff by selling credits on their phone to each other. And that's how they're transacting business, because the currency is not to be trusted.
Right.
So my crystal ball says that we may bring this concept of smart city here in the developed world, but because of a lack of an installed base, we may actually bring those people from 17th, 18th century into the 21st century through these federated energy systems that then power water, wastewater, and everything else. And this is getting a lot of audience from several governments where I have been dealing with of late. They're all ears. So with that background, whoever wants to take it, we're going global now.
Actually, I would try to.
Dirk wanted to say something.
Actually, I wanted to close the loop there, because you started off at the very beginning in why is that decentralized versus centralized, that there was the start of it. Having that said from before, the sensor level to the client right now, that is something I believe in, reduced cost by any. At the end of the day, because you might, the same example as you just go from your crystal ball, which I might borrow you from one day.
Yeah.
We don't know the applications that will be run on those kind of data in future. People might use this kind of data for other things that we have in mind right now. Right now, we think of how to optimize efficiency, how to get control of energy, how to know more. But in future, there might be much more addicted to it, from healthy sector to security sectors to totally different applications. Mm-hmm. So the sensor itself is just a dumb thing that is on site, it's measuring something and giving some digital information into the cloud level where it's being stored, but the analytics behind, that is something different that's being run later on it. And if we are able to create a platform on this one that people can utilize this data in a meaningful way, that is a big
I can see the equivalent of HP OpenView coming back again, or Tivoli from the old IBM days. When Dirk talks about platform, that's what I'm seeing. All kinds of little things hanging, trinkets hanging from it.
Yeah.
John.
Well, interesting. How many of you remember from USA Today an article just yesterday? Anybody remember anything about an article in the front page of USA Today?
My hotel doesn't carry the USA Today, so I haven't been picking it up from the front of my room.
Interesting, right? So USA Today had an article in front page about cybersecurity in the energy space and how we're getting a number of threats from physical and cyber attacks. Now, what's interesting is what, in addition to that news, what they have provided, a to-do list. Anybody remember that? 3 hours after your outage, your food starts to go bad. You need to consolidate your food. 6 hours from there, these additional things happen. If you have an elderly in the house with some kind of medical device that connected to the energy, you don't have energy and the backup power goes out, this is what you do. And then there are steps where the storage of energy runs out. Now the lights in that city or the stoplights will stop working. So there'll be chaos. Now this is interesting because we always talk about our problems and we kind of look at from a utility perspective. Now this particular article kind of gives this to-do list about 6 different things you're supposed to do. And that ties to this smart city concept. Actually, it is not that far away because every single city out there are thinking about it, they're talking about it, they're actually implementing at a different levels, either municipality or not. The question is the integration of that data, who does what, right? So I foresee that smaller cities, in fact, talking to a mayor of Santa Fe last week, and they're looking at, for Santa Fe, how they can make it a smart city because it's manageable, it's actionable because they have a better control of different stakeholders within that community, from transportations to utility and so on. So I believe, and that ties to, it's not that far away because even USA Today giving us this step-by-step process, and that a lot of them include, all of it actually exclude what utility did or does. It's actually how we run our lives in an event of an outage, which is essentially you take the data points and it can go both ways as to what's the exit route versus what happens.
The data.
So we're going to open it up for questions very soon. So Ernie, you want to?
Yeah, just briefly, let me just say this. I actually agree with your crystal ball, but I want to add a little bit of a twist to it. I think, first of all, the reason the third world countries will get there first is because they're not migrating through multiple legacy systems. Mm-hmm. They're starting with that which is best and available right now. You move forward, and you will get there faster. But the other thing, when you look at smart city strategies, and as we see them working with them, how they're emerging, they're really starting based upon what that city needs to do from a couple of different dimensions. One dimension is overall cost, in terms of how intelligence into their smart city strategy can help them. The other is environmental, right? Now, from there, depending upon what kind of utility is within that city's domain, you may see an energy play connect very quickly. You may see one connect indirectly. Even if I'm an IOU, I have an indirect contribution to that city, if for nothing else, based on carbon footprint, et cetera. So as we're working with them, we're actually seeing right? As John was mentioning, people are actively working it. I do think that we don't have a burning platform like some of the other countries have to actually make it happen sooner rather than later. So we'll evolve to get there. There are a handful of cities that made a declaration that we will be a smart city by X. That's great, but I don't think we're going to see that on a wide scale. It's going to be more so driven by their own drivers in those two dimensions I talked about.
Great. So I'm going to make some general observations before we go to questions.
Okay.
And my observations are as follows. Having come from the enterprise IT and networking side, I used to manage the western backbone of the internet for AT&T in the 90s. And we had DS3 lines at the time. That was like top of the line, 45 megabits per second. So internet protocol and I go back a ways. It's kind of like Scent of a Woman, Al Pacino saying, it's Johnny to everyone else, but Jack to me. So IP has been like Jack to me. And I will tell you that it can be quite flaky when you're talking about multi-hop networks and many, many, many nodes. I'm talking in the hundreds of thousands of nodes. So it needs to be managed correctly, and that's why we paid the big bucks to Ernie and Brian and their organizations to do a good job of that. But please understand that standards are not a monolith. If you look at the GridWise Architecture Council framework for interoperability, there are multiple layers. And the hygiene layers form a small fraction of the overall. So you've got transport, network, application, semantic, where you develop the object models. Then you have the business process layers, and then you have the policy layers. If you want true interoperability that generates wealth, each environment that you traverse when you run a use case, a transaction, needs to have well-posed open standards in all of those layers. And unfortunately, a lot of emphasis is put in lower hygiene layers because you get master's and PhD theses out of that. But as you go up the layers, the population gets very scanty. And the reason is because it doesn't interest the nerds who are graduating in engineering and computer science. But we need to bring the arts and the humanities people in, as the professor, good professor told us yesterday, to develop those business process layers. Because a lot of the social engineering problems that we're facing will be addressed there. So that's one point. The other point is that there has to come a point in the paper exercises where empirical testing is necessary. And I'm not talking about test harnesses. I'm talking about real systems, real test beds that can do the end-to-end testing of the use cases. Because until you don't do that, you're not going to develop all the rules for scalability. And you'll have that unfortunate hiccup when you go to commercial deployment. So keep with those thoughts in mind. We have about 8 minutes in which we can ask questions. So if I could get a volunteer who could move this mic around, since you're in the front row. Okay.
I agree with your comment, the crystal ball, about creativity coming out of the third world countries, because there's pain. When there's pain, there's a solution to that pain. When we talk about smart city, is there, what's smart, for example, for Berkeley may not be the same as a concept of a smart city as San Mateo, California. How do we define that? Is there standard smart? And yeah.
Great. So I'll open it up to the audience, the panelists, but I will just say that smart is about value, okay? So every city, based on its demographics and the way it generates wealth, needs to figure out their particular use cases, and based on that, make proportional investments until the marginal cost and the marginal utility become equal, and then you stop. It's like fishing and farming. There's a certain amount you should do and then stop. So anyone wants to follow up?
It's absolutely true. a regional thing. One of the topics we were having at lunch was around water. And there was obviously someone from California there, including myself, and it was like, oh, well, we need to come up with these regulations around water, and maybe California should lead the charge. And it was like the whole table went up over that. It's like, well, why the hell would California lead the charge on something that the Pacific Northwest doesn't care about, or other places? And so I think it's very localized in terms of how this technology gets applied.
Okay, since it's in the middle of the afternoon, I'm going to invoke a little humor now. It's like getting an espresso shot. So the riddle is that how come, according to Scripture, God made the world in 6 days? And the answer is because there was no installed base. So he was able to pull it off in 6 days.
Okay.
So Barry, in response to your point about need, but also no install base, and we echoed that sentiment, it's very important to understand that there are going to be a set of what I call meta-stable states between today's world and that world that we are all envisioning. And it's not going to be a quantum leap. And the reason is because the regulatory framework will not allow it. There has to be an educational process there. And we all need to help educate the regulators to free up, allow the transactive energy models so microgrids can be empowered, have federated systems, have utilities become a partner with the consumer and not see them as a load. And not just have this net zero sum game, have as much decoupling as possible to create new alternatives. Because we can't, I'm a scientist, and I know when, according to an operations research problem, the problem is not well posed. Today, the problem is not well posed. All the constraint lines leave no region of interest, unfortunately. Yeah. We're walking fast in that direction where centralized generation is going away, but we can't just rely on distributed generation in the way it's being offered, little morsels here and there. It has to be done in a coordinated way. Mm-hmm. So more questions. I'm being controversial on purpose to wake you up and have you ask questions. Am I doing a good job?
I'm Riaz Muhammad. Thanks, Dr. Irfan, for asking all the right questions. I know you probably know the answers. You kind of think that you know the answers. You're not saying that. That's fine. On the smart cities, I think we should look at why can't we enable a smart home today? I mean, this is all mine. Energy is mine. A utility is doing energy. There is no relation with gas. There's no relation with automation. And in one way, why we heard about all the IoT today, we heard from Siebel, Google is already doing it with an S thermostat. That's what they are doing. They put a thermostat there. They call it a thermostat. They actually installed a gateway. They're taking all the data. Yes. They started with thermostat. They're adding, with Thread, they're adding more devices. They are already talking energy. They are doing it. I think the utilities should start today to not being just copper wire vendors in the future. They have to do something.
So Dirk, by the way, has a lot of qualification in this space in talking about how do you make the home smart and in an integrated approach. But Tracy, you want to?
Thank you very much, because there was a question earlier about how do we get the consumer educated? And Patty Duran throws out 70% of the people don't really understand what a smart meter is. Most of them, I guess, wouldn't know what a recloser was if it fell on the hood of their car. The thing that's interesting is Google with Thread, Apple with HomeKit, you actually have the consumer now thinking about, I can connect light bulbs, I can connect locks on the front of the door, I can talk to the solar panels. And I think that's what clears the way for smart cities, is when the consumer can actually understand, okay, now I actually understand why there's a smart meter sitting on the outside of my house, because I've got all these other smart things that are in here communicating, and I let all those things in my house, so why am I complaining about the thing that's on the outside of my house?
Right.
Yeah, it starts with that.
Yeah, we've been looking at the space, the smart home space as well, and everybody has been saying for the last 20 years with X10 that smart home is right around the corner, right? And I think in the last couple of years, with the advent of Dirk's product, and there's some other products that are out there, the Lowe's Iris system, the AT&T Connected Life platform, I think finally, when you see Google and Qualcomm with AllJoyn coming into the mix, enforcing multi-protocol translation transactions, I think finally you're going to start to see some penetration in the home. But prior to these recent announcements, these last 12 months, it's all been siloed. Like you're paying $50 for a Zigbee switch that only works with Zigbee or Z-Wave. Right? It doesn't work with Insteon, and if you want Insteon, you have to buy that switch. And so, I think from a protocol perspective, that's finally enabling those kinds of transactions to occur. I think there's a regulatory issue that we need to talk about. We come from a telecom background, and from telecom, we went through this transition. I know, respect Patty, that she said that it not always applies to the power industry because inherent service obligations. However, it is key to note that we evolved from wireline roots, and our first foray into non-reg products was caller ID. And caller ID was the service that was a regulated service, but the box was non-regulated, and you could use whatever box you want. And I think when you see partnerships with Nest in the Texas retail markets and utilities subsidizing the subsidy, which is a wireless term, but it's also applying in the retail markets for power retailers and distributors, you're starting to see the foray there. So you've got that regulatory framework and you have the protocol. So I think in the next 24 months, you might start to see this occur.
So we are at the top of the hour. What I would like to do is just do a lightning round, just any final thoughts, and then I'll make a couple of concluding remarks. So starting with you, Dirk.
I think
after spending this hour here.
One of the biggest success for the IoT, I think we're talking about standards, yes, that is very important because that makes also those information accessible to everybody. I think all of you have a smartphone and know how easy it is to get emails, meanwhile, on your smartphone that is based on standards right there. You don't need to bother around with all these protocols behind. That is one thing. And the customer engagement process, that is one of the biggest next barriers, so that really we add value and a meaningful sense to all these IoT sensors we have there out there in the place to the lifestyle of each of you. That will be one of the biggest next steps forward.
Tracy.
I think it comes back to that thing on the home. The more interoperability around the home, the more education there, the more the rest of this becomes easy.
Yeah.
Right.
As I said in my opening, cost reduction, Metcalfe's law. I'm a big believer that information processing will be done in the cloud. I think those that win are winning because Ernie and I are connecting things. And the cost to connecting those things, $20. Pretty inexpensive. So,
John.
Yeah, I think understanding the value chain and how we can decentralize or centralize, and with that, looking at the standards, because I agree, the standards, without the standards, it would be very difficult to have this smart home, let alone smart city.
Ernie?
I think the technology is there. It's not the problem or even necessarily the challenge. I think the challenge is really rooted in the social side, and it's rooted in the public policy side. If we just think about smart homes, I'll leave you with this one thought. Unless somebody can gain enough value for that intelligence in their home, it's just interesting to them. Utilities have given it away across the country, and the people have literally ignored it after the first 13 or 14 days, not weeks, not months, because it's merely interesting. To the extent you can connect that to the value, you're going to be able to see that grow. And part of that's going to need public policy and monetization models that help explain how people are going to be able to extract that value. I think we'll get there.
Great. And I appreciate all the panelists' input. I will just leave you with a few concluding remarks because you've taken time to come out here. And you can only go back and feel good about it if you felt like you've learned something that you can't go and download from the internet. So as Flavor Flav would say, this revolution will not be televised. So I'm going to share with you a few thoughts that will, shake you a little bit. A lot of you are from technical backgrounds. I'm a plasma physicist by training, recovering. As time goes on, I slowly work towards the humanities and the arts, as our good professor told us yesterday to do. And one of the things I've learned, having been in this country 35 years, is that bragging rights are an amazing force function in this society. So we will negotiate the price of a can of Pepsi at Costco. If it's 30 cents a can, we don't want to buy it, it's too expensive. But we'll go to a bar and buy that same drink for $4 because we want to impress the person sitting next to us and not to make us look like we're cheap because we're not buying that drink. So you see, it's all about environment and how we behave. The challenge is that when we, as technologists, pitch solutions, we forget that we are humans and that we are driven by the same forces that make people make Apple be an $800 billion company. I am carrying a Samsung phone, by the way. And also, light trucks. For absolutely no reason, people are purchasing them. They'll never carry a load in the back. I went to rent a compact from Avis. They didn't have one. They gave me an F-150 double cab. And I've been negotiating it in the parking lot. And after 2 days, I have to tell you that now I understand this myth of the urban cowboy. I get it, why these things are so popular. You just show your indicator sign and people start flashing, saying, come on in, come on in. So I understand this need for power. And this is why light trucks took off. I mean, EVs are nowhere near light trucks in penetration yet. You see that with Xbox. So you're getting my thought here? That until we don't ride one of those thermals, or as a surfer guy would say, that next surfs up, we're not riding with it, we're going to be on an uphill battle. Remember that these tools that we have, these sensors, the merge units, the SCADA, the HMI, are just enablers. But there has to be a force function from society to make all of that have monetary value. So my argument back to you as the industry, as the community, is start thinking of linking these technologies with current cultural trends and look at more the sociology aspect of it to empower people. Then they'll start spending hordes of money on this. And it wouldn't matter about kilowatt hours or dollars. So with that, thank you very much, panel. Thank you, audience, for participating.